in a closed system, the force applied by objects is equal to the change of potential energy, or the negative change of potential energy over the change in x, or the position. So F equals negative du dx when there is a closed system. And this is because generally change in energy is equal to for the integral of force integrated in terms of x. And when we take the derivative of both sides of this equation, we get that energy, or if we assume that the energy starts at 0, then we get the change in energy is equal to force dx, like this. And then when we divide both sides by dx, we get F equals dE over dx. Like that. So if this is true for energy put into the system, that has to go, if the system is a closed system, then no energy is leaving or going. So if we take this as the change in energy in, say, kinetic energy, then the change in potential energy will be the negative of the change in kinetic energy, because it's a closed system. So we know that F is also equal to negative du over dx. So that's how we get that equation. Can't really see. So in problem 9 of the AP practice exam, at time t equals t1, a particle A is observed to be traveling with speed, or let me read the first part of the problem. Particle A and particle B, each mass m, move along the x-axis, exerting a force on each other. The potential energy of the system of two particles associated with the force is given by the equation U equals beta over r squared, where r is the distance between the two particles and beta is a positive constant at time t equals 0. Particle A is located at x equals 2d with the initial speed of v0 to the left. Particle B is at rest at the origin, as shown in the figure above. And this is the problem. So, how do we approach this problem? Well, we start by finding the force. So we know that force is equal to negative du over dx, right? And what is u in this case? Well, we have the equation for u, and we know that u is equal to beta over r squared. So if we take, and we know that r is equal to x because r is because dx is the difference between in position, and that will be equal to the difference in radius of our particles. So we know that we can sub that in for r, and from there we know that F equals 2 r to the negative third, and we know that because that would be the derivative of u in terms of r, which is equal to x. Here's what I've done so far. Alright, where do we go from here? From here we can find the acceleration because F equals ma. F equals ma. So a is equal to F over m. So the acceleration is equal to 2b r to the negative third over m. And we can just simplify that a bit and move the r to our denominator, so 2b over m, just like this. And this is the magnitude of the acceleration of both particles. So now from the acceleration we can find the velocity. So the velocity of particle A is equal to v0 minus that acceleration we just found, because we know that it's slowing down, and right now what we have is just the magnitude. So minus 2b over m r third times t. And then the same for particle B is just equal to 2b over m r to the third t. And this is because it started at a velocity of 0 because it was at rest, so we don't need a constant there. So we have these equations now. So from there we're going to, we don't know what r is. R is kind of what we're trying to isolate, and we can do this by subbing in our value for VA and isolating r, because we know that at time t1, which is the only time that we really care about, we know that v of particle A, the velocity of particle A, is equal to 2v0 over 3. So I just highlighted this equation that we're going to be using. So next what we want to do is isolate r to the third, and we can do this by, first we'll combine all like terms with v0 on one side. So we have v0 over 3 is equal to 2 beta t1 over. And what I did there was I just subbed t1 in for t. So this is what I have so far. It's just to the right of that box. And now if we isolate r to the third completely, we get that r to the third is equal to 6t1 beta over v0 m. And now what we can do is substitute r into the other equation, and it looks like those times will cancel out, so we'll just be left with a nice number that relies only on v0. So from there, if we combine these two, VB is equal to 2 beta V0 M over 6 M T1 beta times T1. So this is what we have right at the bottom. And then obviously from here we can simplify this to make it a nice clean number by canceling some terms in the numerator and denominator out. And I'll just write out what that is. That would be equal to V0 over 3. Alright, great. So we have our answer, and now we need to know whether it's moving to the left or to the right. Well, the velocity sign, so whether it's positive or negative, will determine this. So because the other particle A, is moving to V0 over 3 to the left, and this is a positive, we use this as a positive velocity here, we know that the other particle B, is moving in that same direction because it has that same positive sign as the first particle. So it's V0 over 3 to the left, which is option B.